Okay, so I'm assuming at this point that you've watched a little bit about transformation basics, and which is a review. Maybe you didn't see it presented like that, so it might be some new ideas for you. But I want to turn to our function f of x equals sine x and think about the vertical transformations. Of course, if I'm talking about vertical transformations, I'm talking about things that happen outside. So let's start with the picture of sine x at 0, input of 0. I have an output of 0. And from there, it increases, reaching a maximum of 1 when the input is pi halves, getting back down to 0 at pi, and then circling through the negative values and coming back here at 2 pi. 2 pi, pi, 0. Okay, so this is pi halves. This is 3 pi halves. This is a maximum happening at pi halves as an input, 1 as an output, minimum happening at pi halves as an input, -1 as an output. Okay, so vertical transformations. What are things that we can do to f of x? So first of all, I can multiply the outside. This is intuitive, so multiplying by 2 should make it bigger, and it does. Every value in the output is multiplied by 2. So this becomes much bigger, and this becomes much smaller. 0 is still 0, right? This 1 now is sitting at 2. That's a maximum at 2 and a minimum at -2. So that's having a multiplier outside. This number is called the amplitude. The amplitude is the distance from the midline, which we're going to talk about next. In the case of sine x, the midline is at 0 to the peak or the valley. Another way to think about it is max minus min divided by 2. Because if the top is at 2, the bottom is at -2, then the distance between them is 4. And if I take half of that, then the answer is 2. That's my amplitude. Okay, so this number in front is just telling me how big the sine wave is in terms of how high up it goes and how far down it goes. If I stick a negative in front, then there's a different effect. Go ahead and clear this out. Okay, so I've got my sine wave starting at 0, 0. If I look at, so this is, I'm going to use different colors here to signify. Then let's say g of x equals negative sine x. So what happens? Well, we know that multiplying by -1 is a flip. Since this is an outside thing, it's a vertical flip. So this is going to be the impact of having that -1 be there. So this is g of x, and this is f of x. Okay. Third, let's add in something with the midline, so a shift. Just clear this out. Then we're going to do some practice, kind of put them together. Okay, so again, here's my axes. There is a negative side to this, I'm just not drawing it. Okay, and so let's say that I do, this is my f of x equals sine x. Let's say that I want g of x equals sine x minus 2. What happens? Well, again, using my little table analysis, -2, this is outside, so that tells me that it's vertical, and it's a shift because it's plus or minus. It's intuitive because it's outside, so -2 should be a drop of 2. I'm just taking this whole thing down 2. So one of the ways that I would kind of think about redrawing this is thinking mentally of a new midline, which is down here. Let me start a color. So mentally, I got a new midline. And I'm going to draw my shifted function, g of x. It's going to be the exact same thing, but now instead of starting at 0, 0, I'm starting at 0, -2. Instead of the max happening at pi halves 1, it's happening at pi halves -1. So really that should have gone all the way up to the same point as that. And then my bottom is not happening at -1. My bottom is happening at -3. Now, this is the point where my sketching becomes so bad that better to just turn and use Desmos. So let's just switch over to Desmos real quick. So we were looking at f of x equals sine x. And then we're looking at g of x equals sine x -2. So you can see that the red is the sine x and the blue has just been shifted down. So everything has just been shifted straight down 2 units. So I was sitting at pi halves 1. Now I'm sitting at pi halves -1. And what I was saying, this point should be exactly the same as this point. Right, this one at 3 pi halves -1 now shifts down to 3 pi halves -3. Okay, so that is the 3 kind of main things that happen outside vertically. You can have a flip, you can have a stretch, you can have a shift. So let's take a look at kind of a combo. Stop share here. I'm going to go through the analysis. So let's say I have f of x equals -2 sine x -3. Okay. So how I would break this down is start number 1 with the base function. What does f of x equals sine x look like? I can draw that, or I can just mentally kind of map it out. Okay, I know what I'm looking at here. 2. Now I'm going to put in my amplitude and my flip, because those are the multipliers. Okay, so -2 sine x. What's happening? Well, first of all, there's the amplitude. So this is a stretch times 2, intuitive, times 2 should make it bigger. And then I have a flip, right? So I got to kind of do that. I might do it in 2 steps. Here's my flip. And then here's my flip with making it bigger. Okay, no, yeah, you got to forgive my. So this is the whole thing is this color. The flip itself is just the black. And last but not least, now I'm taking that. And the nice thing about this guy is I can take this off and I can take this off. This is where I am right now. And I might need to start putting on some scale here. This is 2, this is -2. All right, then I got a -3, that's a shift. So third iteration of this, -2 sine x -3. This is where I want to get to. Now I'm going to take this guy and I'm going to shift it down 3, -3. So now what was at 0, 0? This is going to be now at 0, -3. So I'm starting down here. So it's going to be exact mirror of that thing on the top, but I'm shifting everything down 3. All right, let's go back to Desmos and let's look at it. Nice. Okay, my end goal is to get to -2 sine x -3. All right, so I built it up. I'm going to start with sine x. This is my first one. I'm going to change the scale here because I like having my pi halves. So we'll change this to pi halves. Great. Okay, so this is my regular one. Next thing I did was add in -2 in the front. Okay, so I got that flip and the stretch. Right, so I'm flipping it and I'm stretching it out. So I'm pulling it vertically. And then finally, I'm going to add in the -3. So I'm shifting that down 3 spots. I'm going to turn this one off. So you can see that the difference between these is that it's just been shifted down 3. Yep. Okay. Those are vertical transformations in sine world. Next up, we're going to talk about the horizontal. Things get a little dicey. All right, see you there.